Hello, we're back. So Adrian accidentally clicked the end stream button. It was the first time this happened, but it's good to be back. Hello. So those of you who are still in the old event, I think what I just did created a new mini event on the stream, but I think YouTube and LinkedIn have been rebroadcast. I'm not sure about X. So yeah, I'm just gonna wait a few minutes for everybody to come back in, and we can continue with the example. Hang on, let's have link share real quick. So I need to check view on LinkedIn. There we go. Okay, so that's the live. There we go. Hello, everybody. Welcome back. So the only issue is this isn't a real streaming platform. So LinkedIn, YouTube, etc. They're not exactly what you would consider traditional streaming platforms where I could just go on offline and online without the hassle. I have to create events on LinkedIn and YouTube to live stream, which is why the link changed. So if you're back with us, let me know. I'm just gonna wait for some kind of live sign from chat that we're back. Just let me know when that's okay, and then we continue with the example. I'm just gonna give it a few minutes. I'm just gonna run some background music here. Oh, this is great. This is a new kind of chaotic. Okay. I'm not advertise. Why not? All right. Are we back? Hello, hello, hello. Oh, I already posted this. Okay. Thank you, all of you, by the way, who are messaging me now directly. Oh, this is great. Boom, 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 boom. It's gonna wait a few. Okay, it's been a few minutes now. Let's see. Now it's over. All right. Who's with us? Okay, we got a few people live. There's a first time for everything. I'm glad it happened on one of the Thursday streams. Okay, so let's continue with the exercise. Yes. Thomas, is that you? Hello. All right. So one of the concepts of tell, don't ask that might quickly let's say let me gather my thoughts on this. So with any kind of design effort, really what it comes down to is I don't want to over design just for the sake of over designing, to just engineer stuff and abstract things and abstract things and abstract things and abstract things just for the sake of abstraction. Tell, don't ask actually isn't about polymorphism, isn't about classes, and God forbid it's not about inheritance. There's no need for us to actually use inheritance, because the worst thing that you can do in this situation is to say, oh, I'm going to create a user entity, and then I will extend the user with a sender, with a friend sender and a friend receiver and a friend email, and then that's just going to create a whole bunch of I will have one functionality and it will have some kind of weird 4 or 5 different types that are sharing some kind of hierarchy. That's just silly. That's when I see a lot of engineers just stray, where they think object encapsulated programming, especially tell don't ask, is about creating a sort of polymorphic vertical rather than just being very explicit with what it is you want done. Right? So the behavior, if you analyze the behavior of this, I have a friend request and I want the friend request to go out to another user, and I want to do it in a way that I can use the user object for that without breaching encapsulation. Now, I also don't want my user object to become some kind of like very, very detailed God object, right? So what I might do is I might say the user can create this class, and I might actually rename this class. I might rename this class to say this is actually a friend request. If you think about it, right? So this is a friend request, and the object where, right? So I have a friend request, and I have the friend request side, and I have one object that is the sender and one object that is the receiver. And then the user can be such a class that I can say, hey, I want a new friend request, and it'll encapsulate the primary friend request with the name and the email of whomever I'm requesting friends with, if that makes sense. Right? So I might say I have a user here, right? And I would say, okay, request friend, and I'll give it a user. I might do it like this, right? And it returns a friend request. And then I send that in an email, right? So I separate out this part here with that friend request. That might be another avenue of redesigning this entire space. Yeah, Grant, no worries. We did the accidental red button press. It was completely automatic. Usually when Adrian leaves, he uses the red button to leave, and he sent the stream offline by accident. I just restarted it, but unfortunately, when I re-go live using an event system in YouTube and LinkedIn, what happens is that sorry, the links change, so I had to send you a new link in the chat, and it just clicked for me. Thomas, when you sent me the message, did you want to join? Did you want to come onto the hot seat? Because we have like 40 minutes left. You said let's continue together. It didn't click with me what you meant, but sure. Let me share. Let me give you the studio link. Yeah, please don't share the studio link. Thomas, if you're still watching, I sent you the studio link, and you can join me on stream, and we can take it from there. Actually, I'll undo my example because you might have a better suggestion. No, he said no. Okay. Okay. Did I misunderstand you? Did you want to do it privately? Fair enough. Okay, I'll continue then. So the elephant in the room is still that when we design like this, I can quickly get into the problem of, oh, okay, obviously everything in the system that the user does, I will be very tempted to put onto the user object, right? Because I can just naturally gravitate towards this process of saying, oh, this is a user-initiated action. At the very least, it might need something from the user. So I might get this problem where you have a user entity in your system, in your web application, or in a sort of, let's say, a sort of domain service layer or an application service layer, and then there's this giant God object or just enormous router that has all of the things the user can do. Now Thomas joins me. Did you change your mind? Hello. Yes, I can't hear you. Can I put you on stage? Just give me a nod or a thumbs up if I can put you on stage. You'll go immediately live. I can't hear you right now. So if you give me a thumbs up, I will put you on stage. Okay. Okay. Thomas, hello.
Hello, can you hear
Hello.
me?
Yes, I can hear you loud and clear.
Okay.
This is great. This is great.
Cool.
So Thomas is one of our regulars, and Thomas and I met just recently. And Adrian just had to leave, and he accidentally nuked the stream. And now we're back with Thomas. Actually, we're back with Adrian after a haircut. So, where would you take it from here? Like, what did you learn today? What's at the top of your head, just from looking at the screen?
Where would I take it? This is a different question for me because my view of it is in a hardware way. So when I'm doing this, I have an executor, CPU, and a memorizer, memory.
I like that.
And
so we're going actor model. We're going. So you meant CPU? Is that like a?
Is for me a service.
A service. Okay, I like that.
CPU is for me there. It comes. The service comes into the CPU, and then something is doing there. And for example, when I give the CPU something to work, so I have my mail service. Okay, I take my mail service, point, send, and email. For example, this was my example for this. And you actually have a user as a service because the user is doing right now something.
Yes, that's usually the main issue that I see with engineers who don't have a very strong encapsulation of, and I'm trying really hard not to label you because this is a great example. So this is not personal, but I got reminded of an example that usually engineers who go into, let's say, clean architecture or more of a bit of a sort of framework-driven programming, they think that whatever things are doing stuff. So whenever I have like the CPU idea, they are in some way services, right? So generally engineers love putting things into a service class, a manager, right? So these controller classes and the do stuff classes, right? So, but these are all anti-patterns of, I don't know where to put this.
Yes.
Right? So that's the overall idea that we're exploring here today. But it's a good take. How would that service then communicate? Let's say you have did I understand you correctly? You would like to have a user, a friend request service, and an email service.
No, not really. This is what I was thinking about.
Yes.
And for example, you have a user. This is, for example, here the object what is doing something. The user is receiving an email, for example, here, and you have to tell, okay, we have to go to the execution phase where the user actually receives an email from an receiver, for example. We have to write it down first before I can jump into it. For example, if you want to write it down on the last line, just to write user dot receive email. And for example, let's write an email on Thomas, for example.
An address, or do you mean address and the name?
No, also receiver. It has to be a user. Invite receiver poo. In this case, we haven't declared a receiver. Invite receiver is a name and an email, so it's not a user. So it's yes, in invite receiver, yes. In this case,
receiver. So I can do it. I can do it like this. And so you would. Now, how is this different from what I've already written here? So this would be your public API, let's say.
This is the execution. I mean, this is for example, we have to execute it somewhere.
Yes.
And the declaration.
I see. So what you're talking about is a command. You'd like to encapsulate the decision. I see.
Here, you have to execute it somewhere.
That was actually where I was headed with this, because in order to, let's say I can call this a friend request command. Let's say I will put the suffix. I will put the suffix in the class name, even though I hate it, just for demonstrate. Now, outside of this context, I have a user class, and I can tell, hey, I need a new friend request. And I might put the receiver as a user, or this receiver as a user, right? So I might do it this way, and this thing then can return a friend request. Now, where would you send this friend request? The command. Would you make it be self-executing, or would you give it to some service that can execute commands?
Yes, to give it a service who execute a command.
Okay.
This is what I would do.
So you have are you familiar with CQRS? Are you more? Yes. So this is typical CQRS kind of segregation of the decider. This is a decider, right?
But we have here we have here not an asynchron aspect. We have more here a synchron aspect. So it's not really working so much with CQRS.
But CQRS now CQRS doesn't have to be asynchronous.
Yes, it doesn't have to be, but the more the thinking about secure is more separating and not to be restrict on this execution what has to be done before. So it's like the CQRS pattern for me is more a separation of when should I do this, or for whom should I do this. So it's not a tight coupling of time for me. It's more a time. It's more a separation of time coupling.
I love that. I love that context that you now introduce. So that would be temporal coupling. So you're creating a command. Would you put that onto a command queue? Like, do you think that that's somehow able to be deferred, or do you want to actually make it timeless, make it time independent by saying, here's a decision and something will know how to execute the decision, right? So that's
like
going.
This? Yes.
So in the example,
in our case here, we have a coupling here because we have here a mail sender dot send, and so we cannot do this. So it's different from now.
Right. So what you would do. So if I understand you correctly, you have the body and the receiver email, and this is actually what you would encapsulate as the decision. Right, so this is something that needs to be done. This is the friend request email that is a output of the send request command. Right, so I would then return the body and the email.
Yes.
And this thing here, the toasting and
it's
the
outside.
sending, it's in the outside.
Yes, so it's outside of this function. But this is another topic. This is not about this actual topic, what we have done, or tell, don't ask, because tell, don't ask is another topic from this.
But it's a very good point, right? Because we have now made this user, or in this case, our friend request command, we have made it do less stuff. We've decoupled it even more, we've simplified it down, even to the degree that our old functional approach, even though it was simple, we weren't able to do so, right? Because we also had some static functions in here, might be more difficult to test. I mean, some languages might allow you to like invasively mock or invasively like get access to this, but I don't want to go to that direction right now. But I would create the command processor. So what kind of aggregate, what kind of decider would process friend request commands?
Friend request commands. Moment.
I'm trying to type a class that would encapsulate where the command goes.
Who can do this? Who can who? What context do you want to create? Because we have to create it. This is a business decision. This is something business, not technical.
Very good, right? So the tell me what you want me to do with the tell me what you want me to do is a business decision, not an implementation decision, right? Very good. So this is the business context. Let's say I will now God mode, and I will say the business context is we are on, let's say, GatherTown or something similar to GatherTown, a a map, a social space like Zoom where you can walk around.
Mhm.
And I want to create an atmosphere where you can create a friends list for yourself.
Mhm.
So there is, let's say, an organization that
Mhm.
has user accounts, and within
Mhm.
that organization, you have a certain set of friends that belong to that organization. Right? So I might say I have all of the organizations. I have organization. Or let's make it more specific. It's not just an organization, it's a conference. It's a conference that lasts a week, and on that conference you can make friends. Right? So I might say this might be my conference bus. And it can take, what does it take? Does it take the friend request command and the send email command? Would that be meaningful?
I don't know where the conference bus is. Do you mean a message bus? Or
Like
do you mean a
bus,
bus
yes.
to travel around?
No, like a message bus, yes.
Okay.
Like a message
Okay.
bus. Like a message bus. But you can also make friends on the bus, on the actual bus.
Okay.
Right, so I might say process FR friends, and I can say this will always be a friend request, and it will be a friend request command. I can do it like this.
Okay. Okay.
And then I can also have send email, and send email will handle. Right, so actually a friend request email, and I can do this.
The bus itself is doing this. Okay. Okay. Okay.
I could just call this a conference, and we don't have to suffix it with the bus.
Okay.
Right?
Okay.
So now an aggregate.
It's better for me now.
Decider, yes. Okay.
Because the message bus, it's a between for me, so it's a connection between two objects. I think I can say.
Yes. So I'm just going to create this. So this is a friend request email. This is actually the example that I wanted to come up with initially. So I'm just going to create this. Luckily, I have an editor that is very good at this. So I will just hover it, create class, boom, done. It knows exactly what I want. God, I love IntelliJ.
More bigger.
Right. So again, we will continuously run into the same problem where it will continuously ask me to expose private information from the class. Does this make sense now? And obviously the user would then create the command, and then the command would create the email, and then the email would be processed, and then the mail service is now a responsibility of, I lost what I had there in the toast, but I think we copied it from here, right? Yes, so we copied it from here, and the send email will now be doing this. Does this make sense?
Yes, also. Conference is the sending the email, process friend request command.
Does this make sense?
If you want to define it like this, then yes, it makes sense. Right, I don't know your goal.
Well, so
where do you want to go with this?
Yeah, I'm trying to create support for your CQRS idea, right? So I'm trying to figure out what, if you're doing CQRS, what closes the loop. So I've created something that might close the loop, right? Because we have created an email that we're sending.
Yes.
But I need to give it to something. Right? So whomever is calling the receive email command is now getting back a friend request email, right? So if the process friends is handling the command and it's calling receive email and then send request, then this thing will have to call send email with whatever this is returning, right? So, but I needed that context because otherwise this doesn't go anywhere. Now, it doesn't have to be in process. Like this can be either, this can process and then it returns the email, and then the email is something that I say this send email, whatever whatever the friend request returns, right? So I can chain this like this, and I can make it very, very tightly coupled. or I can receive this friend request from a message queue, and I can process it, and then the return value that I get, I can put back onto the message queue.
Yes.
And then that thing will then call send email on the same class, or a class that is sort of very close to this context. Is that what you had in mind?
Yes. Normally, when I have this process conference, for example, well, yeah. I think now I check it. What you mean? The conference is a process where it is connected to the message bus. And the message bus gets the command now, and so it's receiving the commands by the process friends, because the process friends is watching at the message bus all the time.
Exactly.
And when there is a new message in the bus for this conference, then it's executing it. Okay, now I check it. Now I get it.
Yes, and I needed something that establishes locality in some way, right? Because if this process wants to asynchronously through a message bus communicate with send email, they need to share some kind of locality. Like, what is our shared context? Is it the same database? Is it the same? Because otherwise, if I don't have locality, then I need to put a lot of information into the system. Like, how do you want the mail service to be configured? Or are we on the production server? Are we here? Are we there? And that would also then make it much easier to test. Now, obviously, I'm giving this a lot less rigor than we did initially with Adrian. Do you have any questions here?
Me?
First of all, are you having fun? Are you having fun?
Yes. It's a new experience for me to be live.
So, one of the things that I enjoy about programming in such a way, because I know that this can quickly become convoluted, because sometimes I will decouple it in a certain way, like we did here with the receive email and send friend request. And sometimes it doesn't. There are accidental structures that we end up creating, like this, that don't make sense in a wider context, right? So you might end up actually creating DTOs, right? So this is very much reminiscent of a DTO, and what you might end up doing is that you might have a GraphQL server that sends you back a DTO, and then you hydrate that DTO into some kind of processing class, like a service layer, and then that one also produces some kind of class. So sometimes it's a class, sometimes it's a DTO, sometimes it's a string, sometimes it's a primitive, sometimes it's a value object in domain-driven design terminology. And then you keep diluting your type system, because there is never really a very clear distinction of what is doing the main decision, what is doing the main sort of state transfer.
Yes.
Because if you zoom out a bit, and I go from scratch one more time, until don't ask, what is the real problem we're solving, right? So if I draw the problem from a slightly different perspective, because I have at the very beginning of this session somewhat biased the solution to an imperative problem, right? So I can think about it, this friend request idea, outside of the context of a user, right? So I can say there won't be any user state involved with friend requests, right? So I might say I will have, in the context of, let's say, a conference, of some tenancy, some locality, some some aggregate boundary that I say within this space, friends are unique. I might say there is such a thing as a friend that binds together user 1 and user 2. And user 1 and user 2 is equivalent to user 2 and user 1. So I create tuples. Right? I might decide that that's how I want to run this kind of let's say, structure. That I say there are such things as friends, and friends have IDs, right? So these would be a number array, and let's say I will have an implicit rule that they are in the IDs are monotonically incremental in numbers, and I want them sorted by integers. So it's always 1 and 2. It's never 2 and 1, right? So I can easily deduplicate them. And I might say, okay, and I will have friends here. and I will have user IDs. Now I'm already having issues here with user IDs, but now the issue becomes different. So this now becomes purely a persistence problem. Yes, I did. These friends now become purely, I love my linter, but in this case, it's just, thank you, linter. But I want it off screen. In this case, I just wanted purely encapsulating that one thing I want to create. I just want to create new friends, right? So I'd say new friends, and 1 and 2. These two are now friends. And new friends, 5 and 10. These two are now friends. And I might validate it in such a way that the friends have to be different IDs, right? So that in the constructor, I would immediately validate that it has to be a greater than 1 array. It has to be exactly length 2. The IDs have to be different. It cannot be non-numeric. So I can immediately create a very strong value object. In DDD terminology, this would be a value object. So now the real context for my decision is where are the friends lists stored, right? So, and the real important question here is, are the friends lists symmetric? So if I'm a friend with you, are you a friend with me? If you
define it, yes.
Yes, so if I invite you, are you on my friends list? If you don't accept, let's say you have to accept because I'm sending you an email.
No, right? If you define it, so it's not, then it's not. It's not on the list. For example, if you take it on a list on a regular table, like an SQL table, then it's not in the list of the friends.
Yes. So that means that I have to separate out confirmed friend requests from in-flight friend requests.
If you want to include this logic, yes.
Exactly. And then that would be the main separation for my context, right? So perhaps that was the main context that was missing in the previous example, right? Because I already went too far. I already skipped over that detail, right? So the whole idea is that friends come in 2 types, confirmed and pending, right? So I might have a confirmed friends list. I can have a friends list. These are the confirmed ones. And I can have the pending friend requests. And these are the other ones. Right? So now this is starting to make sense because now this terminology is actually reminiscent of something that you might actually find in the UI. It might be 2 tabs on the UI. Or you might go to your friends list and the friends list might have a little button there to say, okay, show me my requests. Right? So now this is what object orientation is about. We want to get it back down to human concepts so that we will actually shape it in such a way that perhaps maybe the UI doesn't capture it exactly like this, but at least a human who is used to dealing with applications like this, they might envision it in some conceptual way around these terms. I have a friends list and I have pending friend requests, right? I don't call my friends list the accepted pending friend requests, right? Because that would be that sounds too wordy, that's too Spartan, that's too technical. But there's nothing technical about. Go ahead.
Normally, it's when you're in the real world and you send, for example, somebody, giving somebody a friend request, for example, a paper, giving to other people, then you have no pending friend requests. You think, okay, you have, but you are not thinking, okay, I give him this and I want, and I'm remembering that I'm getting the answer. I'm waiting, also not. I'm only getting it. If I'm getting it, then he is in my friend list.
I agree.
But when I'm not getting it, then he's not in my friends list. So
the adjective pending is unnecessarily
pending. When it's like when, for example, if the message is in a message queue and it's processing. So it's in the system actually. So we haven't written it down in a separate list. We can do it, or we don't need it, but we have to define it first.
So in the
how
context,
would you do it?
So I just removed the adjective pending, because what you said made perfect sense. Like that seems to be an internal state of how the friend request might be processed, but to a human that might be completely unnecessary. Now, how I would do it is I would say there are such things as friend lists, and on the friend lists, what you can do is when you get an instance of a friend list, you might say, hey, I want a user's friend list. Right? So the constructor of this might actually take in some kind of user identity or some kind of identity, let's say, some kind of identity that I can use or I get injected with somebody's connections, let's say. And then the output of that is a friends list. Or let's say I add connections here and I have a user array. Right? So those are
normally when you're creating a friend list, then it's empty.
Exactly. So normally it would be empty. But now I'm talking about a concept where I'm separating out the creation process from the hydration process. So I don't have an ORM here. I don't want to do the whole entity setup. But I just want to create the aggregate, which would be the friends list in this case. Right? So this is the friend lists. And this is an aggregate of requests. So this is a repository of requests. Now, the funny thing about requests is that the requests don't belong to anybody. That's really interesting. Right? So for the request to actually make sense, if they are not bidirectional, if let's say the UI doesn't disclose that I've sent it, right? So we just have a friend request. It is,
and the friend exception.
Yeah, so there might be a friend request and it might have 3 informations, right? So I might have 1 and 2, and I say the sender was 1, and here the sender was 10, right? So I might have
make it like Adrian likes it. You put it first the sender and after the receiver.
Okay, so it's an array. So it's an array that's semantically sender ID and receiver ID, right? So it's graph oriented, right? So it's going from this person to that person. I don't know how to type annotate that kind of array right now off the top of my head in TypeScript, so I'm just going to leave this here. Okay, I like that distinction. I'm just going to create an example that makes sense. Okay, so here user 1 is sending a friend request to user 2, and here user 10 is sending a friend request to user 5. In that case, I might not even use the array. I might say sender ID is a number and receiver ID is a number, which is very reminiscent to what we had earlier.
Or if you want, and I prefer it, like using objects, not IDs, because with objects, I'm more clear about it.
The pair or just one of them? A value object representing the identity or the pair? What's the pros and cons here?
Yes.
Where you said you wanted objects. Right. Like why? Because there was something very intuitive about that, right? Because it can.
I would say an object who is representative of the person itself.
That you said enough.
And
maybe this is a person identity.
Yes, person identity. Yes.
Right. So it is something that can identify a person, but without carrying all of their data.
Yes.
Makes sense.
Because it's more natural for the brain to think about it, because then afterwards in the class, for example, friends, you can define the rules. You can define the rules.
And I can now define the ID actually as a string, and I can have a UUID, and I wouldn't have that sort of monotonic problem with the IDs previously, where they could be numbers and they had to be numbers and they couldn't be negative, etc. So
now we can have an example for tell, don't ask in this situation, because now we want to clarify if it is the sender and the receiver the same. So we can tell this the person identity.
So the friends, right? So I can have an equality here. Now, how would you check? How would you? So you want me to type in equals?
Yes. If it's asking for equality, yes. If it's equal or not, yes.
And what would you?
So you can check it right now.
And what would you put in here?
But you have to put in the person identity itself.
Okay, but do I make the ID public then?
No, you don't need.
I mean, you want me to calculate a hash and do it that way?
Okay, probably I'm stuck in here a little bit, but normally I don't need public IDs here now, right now.
I need. How would you check equality? Can you just run me through how you would check equality here? Do you just want object equality on the friends, that you would say, hey, if sender ID 3 equal signs receiver ID, then throw, hey, can't be your own friend?
In the friends.
Okay.
It should be in person identity, the equality.
Okay. The equality. So
because
you want me to do
here
exactly?
I have it now, not public. It's protected. Sorry, it's not public. It's protected. So I have not the problem when something is changing. Then
for something as simple as value object, we can say this is going to be public read only. So I'm going to make it immutable, and then an equals can be as simple as another identity. Like I can have other. It's going to be a person identity. And then I can return. Then I can return this ID equals, or let's say 2 equals on purpose other.id.
Yes.
Okay. This is what
because
you wanted.
Now when something is changing, for example, in the ID process, for example, it's not a string or it's not a string.
It might become a composite.
Then
I might
you have
introduce
everything here declared, and this is what I think the principle is telling you. So everything what's related to each other has to be on the same space. I will say.
Yeah. So
space.
So even though this is public, this idea that I need to compare an identity to another is telling, hey, I'm telling you, hey, check if this is the same person, rather than asking you for the ID and then copy pasting this one line across the entire code base whenever this check is necessary. Right? So we are encapsulating this behavior. Even though this might seem, even though this might in the Java space might become very much mechanic, because in the Java space we actually want to check if it's not the same memory location, do 2 objects have identical value, right? So if you're comparing to them, but that's a little bit more anemic. It's like meaningless, right? So this identity is rich in meaning, whereas a typical hash code and equals implementation of, let's say, a POJO in Java might be a little bit more mechanical. This is a little bit more semantic. Okay.
Yes.
Now
we don't have to be mechanical. We can be more business and semantic and so on. It's no problem.
Okay.
Just more logic. But now we have, for example, here the person identity. This is where I want to come with, because now we have an example of tell, don't ask. This is where I want to go with you.
Okay. Can you guide me?
No, we already have it here. Person identity is checking equals, and so we have this pattern here. And if you want to continue with
yes, I would like to continue with the friends request. Yes.
Okay.
Because the friends request is interesting because in most cases where I see developers coding in this kind of paradigm, so I'm highlighting here the friends request. The biggest issue that they usually run into is if something doesn't have a primary ID, if something doesn't have like a natural compartment where it goes, they usually say, oh, I don't know where that fits. It's going to be a service of some kind, right? So so I can immediately see somebody just write, oh, this is the friend request service, because I don't know, because in itself, in the context of the conference or the tenant or the organization, this is a singleton, right? Because the friend requests are transitive, right? So when you're friends with me, I'm friends with you. It doesn't belong to either one of our repositories. So it would be silly to save for each user to send each friend request twice, from your side and from my side, right? So a graph database or some kind of set database, like maybe a Redis set, for example, might be a better example of how to put this into a database. Because if you're doing it in a traditional sort of SQL way, you might actually accidentally get duplicates of 1 and 2 and 2 and 1, right? You can send a friend request to me the same time I'm sending a friend request to you. What happens? That's an interesting problem to solve, because if we both send requests to each other, maybe we should allow that use case, but then just auto accept. When that happens, just confirm it, right? So maybe confirmation is the equivalent of you send a request to me, and then I use the same technology to send a request to you. And whenever that happens, we become friends, right? So maybe we can model it that way. And a lot of engineers usually don't think about it this way because this is hard to express in the database side. But it's a natural, very simple, even primitive API if you look at it from like a purely object-oriented perspective. So from the context of friend requests, all that I really care about is that I say, hey, persist a friends, and I will rename this now to friend. I'm aware that there's a friend request class above in this file, and I will just call this a friend request, a friender, right? And I'll just say, just persist this, please, right? So whenever a friend request comes in, I will persist it. And if this is the first, and now there is logic here. I would say, or rather, I would say validate the friend request. Whenever a new one arrives, the bus calls this. Whenever a new one arrives, I just have to make a decision. If this pair is going into the database the first time, then I'm sending an email because the other person doesn't know. If this already exists and it's coming from the other direction, then invalidate invalidate that pending email and confirm their friend. Right? That's the logic.
Create and add it to your friends list.
Yes. So there's a decision of, do we need to send an email? Right? So the decision isn't, do we need to send an email? The decision is this the first time we are in contact? Yes? Then send the email. Like, that's the point. That's the decider pattern of tell, don't ask. Right? So I'm telling you, here's a friend request. If this is the first time the system sees this direction, and there isn't the other direction, then send an email. See, because now I'm already also deduplicating. I'm also not sending an email if you do it accidentally the same time as I am. Right? So, and it's also handling the case that I've sent a friend request and then we unfriended each other, and then we might refriend each other again, and these events became out of order. Right? So if I'm doing tell, don't ask with like very primitive values, where I'm taking the user out of this equation, I'm also opening the doorway, or at least I'm making it a little bit easier to make this friend request loop more asynchronous friendly and idempotent. I'm sort of opening the doors to make that easier for myself. And the more asynchronous friendly and idempotent the API is, the more easily I can test it.
Mm-hmm.
Does that make sense?
That's right.
Yes. I don't want to go into a detail about writing this down into code, because we are on time, and I would like to wrap it up here.
Yes, I have to say probably I will get a phone call in a minute, and when I get the call, I have to quit.
Okay, it's 6 p.m. So this is exactly how much I wanted to talk about today. We can stop it here. I see we have no questions on. I'm very sorry about the stream hoopla. It happened, but it allowed us to get a hot seat guest onto the stream very quickly. I really enjoyed our conversation. I just noticed that I forgot to turn off the banner. Oh, sorry. Thomas, thank you so much. I hope you enjoyed this.
Thank you.
Let's stay in touch. And for those of you who have actually managed to find the second stream, this is stream number 2. This is the previous one if you want to watch it from the beginning. Thank you so much, and thank you for being patient with us. We'll see you next week on some hot topics on Tailwind and AI discussions, especially for CSS in the front-end React world. It's going to be super exciting. I'll announce the Thursday topic by the end of this week. It's going to be very similar to today. We're sort of going into a little bit more craftsmanship. So, as always, thank you for your time. You're awesome. Thomas?
Thank you to be here.
And take care.
See you.
Bye.
Bye.